Let's move on to example 4 in our sampling distribution section with standard error. Now, an education finance corporation claims that the average credit card debt carried by undergraduates are normally distributed with a mean of $3,173 and a standard deviation of 1120. So question 1 is, what is the probability that a randomly selected undergraduate has a credit card balance of less than $2,700? So the first thing is, let's take a look at this information up here. So this gives us mu 3173, and then the standard deviation of 1120. And remember that is the standard deviation of the population. All right, so let's move the question up. So we are looking for the probability that X is less than $2,700. Now let's note a couple things. That's not an X bar. This is not a sample mean. This is the probability that I select one person and their credit card balance is less than $2,700. But I do want to convert this to a Z value. So Z equals 2,700 minus 3,173 over, now I'm going to write the formula up here real quick. So I want to show you the difference. So that's what happens when the formula to convert an X value to a Z value when you are only selecting one person. Now when you are selecting multiple people, a sample, more than one, it's going to look like this, where you have the X bar involved. Okay, so that's not what question 1 is asking. So just because you have one person, that's why we get to use the single standard deviation of 1120. And that is going to equal negative 0.42. So converting this, we have X is less than 2,700 is now Z less than negative 0.42. And when we look this up into a table, you could see that it's 0.3372. Now I'm going to draw the normal curve here so we have a visual of what's happening. So 2,700 is over here, the mean of 3,173, and we wanted this area here. That's exactly what the normal table told us, so 3,372. So the probability that the card holder, I selected one person, has a balance of less than 2,700 is 0.3372, or you could say there's a 34% chance that that one person has a credit card balance of less than $2,700. All right, so question 2. You randomly select 25 undergraduates. What is the probability their mean credit card balance is less than $2,700? So here you are actually taking a sample of more than one person, and so now we're going to use the standard error, not the standard deviation that's given in the problem. So let's write out what we have, or what we're being asked. Again, we got our normal curve. We have 3,173 in the center. We have 2,700 over here. And we are looking for less than 2,700. So this is what I want. But when I convert it to a Z value, we got to be very careful, because the formula, when you have more than one person, we have to use the standard error formula. And I'm actually going to write out the full formula here, just because I haven't done that yet. And that's going to be 2,700 minus the mean of 3,173 over 1120 over the square root of 25. Now, to be very careful when entering this into the calculator. We get negative 2.11. So the probability that X bar is less than 2,700 is the same as the probability that Z is less than negative 2.11. Now when you look up negative 2.11 in the normal table, we get 0.0174. Now, what's the difference between these two problems? It all comes down to, were you asking about one person or were you asking about a sample of more than one? Now, what we have is that there's a 34% chance one undergraduate will have a balance of less than 2,700. But there's about a slightly less than 2% chance that a sample of 25 students will have a mean balance less than 2,700.